Welcome students, myself Rahul Kotkar, and in this video we are going to discuss about the chapter Mechanical Properties of Fluids. It's our lecture number 11. In the previous lecture we studied about the capillary rise, capillary fall, as well as we studied the expression for height of the capillary rise or fall by using the two methods. One is called pressure difference and other is called due to the forces. Now in this lecture we have to study about the phenomenon related to the hydrodynamics. Means till to the previous lectures in this chapter we studied about the hydrostatics, means all the phenomenons associated with the liquids at rest. But from this lecture or from this video we are going to study the phenomenon which are related to this branch hydrodynamics. So what is the hydrodynamics? So that is the branch of physics which deals with the study of property of the fluid which is in a motion. In short, what you called, it means the study of fluid which is in a motion. It's called hydrodynamics. Study of fluid in motion means when the liquid is moving, then the study of that such liquid is called hydrodynamics. Then in which we have to study the different concepts, but before studying some concepts we have to understood some terms related to this fluid mechanics. So first one, steady flow. What is a steady flow? The pressure or velocity of the fluid remains constant at a given point over the time of flow. Means if suppose we consider the liquid flow, in which we observe that the pressure or the velocity of that fluid which remains constant at the given point over the time of flow till that flow is continue. The pressure and velocity at a particular point will remains the constant, that is called steady flow. Then next is your flow line. What about the flow line? It is a path of an individual particle in a moving fluid. Means if suppose, just consider as similar to the diagram, we consider a pipe, and in this pipe we consider the many layers of liquids. As many layers of liquids are produced there, so one such a liquid path along which the fluid is moving or particle of the fluid is moving. And that's why here the reason is given. If we consider there, this is the pipe and this pipe through which the liquid is flowing. So let's suppose we consider that this liquid particle is moving like this through this tube. So what is the flow line? It is a path of an individual particle in a moving fluid. When the fluid is moving, the path followed by a single particle is called as flow line. Streamline. Next definition is your streamline. What is a streamline? The tangent drawn to the flow line shows in the direction of velocity of flow at that point. Means as you draw the tangent to the flow line in the direction of velocity of the flow at that point. If suppose we consider that this is the pipe, this pipe should have somewhat curved surface. Now this is the liquid flow. Just a bit. So in this case what we have this is the pipe, but this pipe somewhat curved. It looks somewhat straight. Now we consider these are the flow lines. What is a flow lines? That you know, that is a path of the individual particle. moving through a fluid. Okay, then in the next step what we have, streamline. So what is a streamline? It is a tangent drawn to the flow lines. These are the flow lines here. Okay, this is the flow line, this is also the flow line. Okay, and as you draw the tangent to this flow line, tangent drawn to the flow line in the direction of velocity of that flow. Okay, this is the direction of velocity of this flow, and as you draw here the tangent to this one, so that is nothing but what, the tangent drawn to the flow of line identical for a given flow. Okay, means in short you can say here, for a steady flow or streamline flow, the lines are identical for steady flows. Okay, means as you consider that if the flow is steady, okay, for that flow, streamlines and flow lines are identical. Okay, streamlines and flow lines means what, if suppose here you consider that this is your somewhat steady flow. In that steady flow means here the straight lines are there, so this flow line, as well as in case of this is the flow line and tangent drawn to this flow line in the direction of velocity. Okay, both are the same, this one and this one both are the same. Okay, for a case of steady flow. Next is your flow tube. What about the flow tube? So the imaginary bundle of flow lines bound by an imaginary wall, it's called flow tube. Okay, means there are many more lines are there. Okay, so all these imaginary lines are bound by imaginary wall. Okay, and so this bundle is called as flow tube. Okay, then next point, laminar flow or streamline flow. Okay, look the words laminar or streamline flow. It is a steady flow in which the adjacent layers of a fluid move smoothly over each other. Means in short, the layers moves parallel to each other. Okay, or you may call simply, as you observe first the diagram. First you observe this diagram carefully. Okay, so what you observe here, you observe there are many more particles present here, and these particles are moving simultaneously. All are reaches, okay, at a particular point, and okay, you observe there. So what is the meaning here? It shows that it is a steady flow in which the adjacent layers of the fluid move smoothly over each other. Okay, that flow is called as laminar flow or streamline flow. Either you can say like this also, the liquid flow in which all the particles are moving, okay, with a same velocity at a particular point, or you may also call the velocity of a liquid molecule or velocity of the liquid layer. Suppose I will consider this layer, which is a shown here a dash dash dash. Okay, the velocity of the liquid molecule at a point is equals to constant. This velocity is equals to constant at a given point. Then and then you can say here the flow is your laminar or streamline flow. Okay, so again listen what I am saying. If the velocity of a particle at any point in a given liquid flow remains constant, then it is called as laminar or streamline flow. You can observe here from this diagram what does indicates. Okay, so these layers are moving with this particular velocity, and the adjacent layers move smoothly over each other. Okay, so if suppose you consider the pipe, in this pipe what you can say, there are many more layers we consider. So the layers which are closer to the wall of the pipe are stationary, and as you are moving inside the pipe, okay, as you are moving inside the pipe, the innermost layers, okay, from wall to the center, the innermost layers moving fastly, means layer of this particle, center layer of this pipe is having a more speed. Okay, then next is your turbulent flow. What about the turbulent flow? So the rate of flow very high, the particle moves with various velocity and with different directions. The flow pattern changes continuously. Okay, now as you observe this diagram, you can observe the many more particles are there. These particles are moving with a different speed or velocity, and now what we can say, the rate of flow of is very high. Okay, the particle moves from various velocity, means different velocity, okay, in the different directions. The flow pattern changes continuously. You may observe the following diagram also. Okay, what you have, you observe there are the different directions produced in this diagram. So because of what? Because of the high flow, the particles are not maintain or not have their harmony. They will not move smoothly as to the laminar flow, and what happens? The particle changes their velocity as well as the direction of motion also. Then we can say here about this both the comparatively. Okay, you observe simply the particles moves in the second diagrams anywhere, but in the first diagram they are moving with the certain rhythm. Okay, so next point, that here we have to start the difference between the streamline flow and turbulent flow. Okay, so I just told the definitions to you as similar to the streamline flow. In case of streamline flow, what you say? In case of streamline flow, you may say that the rate of flow of liquid, okay, in case of streamline flow, the liquid flow in which the velocity at any point is remains constant, so that is called as streamline flow. In other case, turbulent flow, in which what you say, the velocity of a particle at a given point is not remains constant, such a flow is called turbulent flow. Then second number means first distinction point, the smooth flow of the fluid with velocity smaller than certain critical velocity is called streamline flow or laminar flow. Okay, once we consider a certain velocity below which or smaller than that the velocity of a liquid flow, okay, is known as a streamline flow. That particular velocity is called critical velocity, and remember, below which this critical velocity the flow of liquid is said to be streamline flow. What about the turbulent? The turbulent, or you may call also unsteady flow of fluid when its velocity increases beyond the critical velocity. So what is that? Irregular or unsteady flow. Okay, in which what the particle are moving with a different velocity. So what happens? The velocity increases beyond critical velocity. Then you call that flow as a turbulent flow. Okay. Next point is your, in case of streamline flow, velocity of fluid at a given point is always constant. Okay, remember this point is noteworthy. The velocity of a fluid at a point is always constant, means in that liquid flow you may consider any point. So if the velocity remains constant there, then what you can say, that flow is what? Streamline flow. In case of turbulent flow, the velocity of fluid at any point does not remain constant. Means, okay, that liquid is flowing in such a way that you can't say there is the presence of constant value of velocity or liquid layer. Next, two streamlines can never intersect. Okay, two streamlines can never intersect because they always flows in the parallel direction. Okay, then in case of turbulent, at some points the fluid may have rotational motion which gives rise to eddies. Okay, means due to the rotational motion of the fluid, what we observe, there are the formation of eddies. Eddies means what? It's like a wheel. Okay, view. Then next point, streamline flow over a plane surface can be assumed to be divided into the number of planes layers. Okay, in case of streamline flow, what we consider, that we consider that the flow of the liquid may be divided into, okay, if suppose we consider that this is a pipe through which the liquid is moving, so the layers of the liquids are considered to be here. Okay, means this liquid is divided into the number of plane layers. In the flow of liquid through pipe of uniform cross sectional area, all the streamlines will be parallel to axis of the tube. Okay, so let's suppose this is the axis of tube. Okay, and all the streamlines like this, all the streamlines are parallel to what? This axis of tube. Okay, in short, that here you have to just mention that what is the important thing we are going to mention. Then in next class, in case of the turbulent flow, a flow tube loses its order, particles moves in the random direction. Okay, means as they lose their order, so what happens, these particles are loses their order and moves anywhere or in random direction. Okay, the next point is our critical velocity and random number. In case of critical velocity, that is denoted by Vc. So what is the critical velocity? A certain velocity above which the flow is turbulent and below which it's streamline. Okay, means this velocity is what? Boundary line. If you are below this, you have observed to be streamline, and if you above it, you observe to be turbulent flow. So in this manner, the certain velocity above which the flow is turbulent and below which streamline. So according to the Reynolds number, critical velocity is given by, what is the critical velocity? It should be given by Vc is equal to Rn eta divided by rho into d, where Vc is called critical velocity of the fluid, Rn is called Reynolds number, eta is called coefficient of viscosity, rho is called density of fluid, small d is called diameter of the tube. Okay, so in this manner, this is formula for critical velocity. Now according to this formula, or using the formula of critical velocity, we can design the formula for Reynolds number, which can be given as Rn is equals to Vc into rho into d divided by eta. What is the Rn? Rn be the Reynolds number, as you observe the description above. Okay, so here this Reynolds number is a pure number. Okay, what is the meaning of this pure number? Means it should be the not a negative number, etc., etc. It should be the pure number. Okay, then these are the conditions for Reynolds number. What is that? If Rn lies between 0 to 2000, then the flow of liquid is laminar or streamline. Okay, remember what I am saying, the value of Reynolds number is observed to be between 0 to 2000, then the flow of liquid is said to be streamline. Second thing, okay, these numbers indicates what? The value of Reynolds number, and as per that you can decide. Okay, if suppose the number is your Reynolds number is 2000 to 3000, so in which the flow may changes to laminar to turbulent. Okay, means the laminar flow get converted to the turbulent flow if the number, that is the Reynolds number, have the value 2000 to 3000. Next is your, if Reynolds number is greater than 3000, then the flow of liquid is turbulent. Okay, so remember these values gives us the idea. Means as you calculate the using all these parameters Vc, rho, d, eta. Okay, so using that you can get the value of Reynolds number, and this Reynolds number have a value, and its range will decide what is the nature of flow. It may be the streamline or laminar, it may be your laminar to turbulent, just converting, or it is your actual turbulent flow. Okay, so all these are covered under these conditions. Then next point we have to start, that is viscosity. So what is the viscosity? So some concepts we have to understood. First one, viscous force or drag. So the tangential force which opposes the relative motion of adjacent layer of fluid. So remember what is this? It is a tangential force. Okay, means force acting along the tangent which opposes the relative motion. That is useful to what? For opposing the relative motion between the adjacent layer. Means suppose here the two layers of the liquids are flowing like this, then what is the tangential force? So that is the force acting like this. Okay, which opposes, okay, on this one also, on this one also, the force acting in such a way that, which is the tangential force which oppose the motion of the adjacent layer. Okay, so remember that in common the topmost layer is moving very fast. Okay, the topmost layer is moving fast, then bottom one having a less velocity, less velocity, less velocity, and finally this is a stationary flow. So in this manner what you can say, this particular velocity of a top layer is always greater, okay, and at the bottom it is always 0, and it decreases from top to the bottom. Okay, and so why this so happens? Means suppose this will have a 20 speed, this one have a 18 speed, this one have a 16, this one have a 14 speed. Okay, so why this so occurs? Because of the tangential force acting on a layer which opposes the relative motion between the adjacent layer. Okay, and this is nothing but your viscous force or viscous drag. Now the definition of viscosity. So viscosity is that property of fluid by virtue of which the relative motion between different layers of fluid experiences the drag or viscous force. Okay, means what you can say here, this viscosity is the property by virtue. Virtue means good thing. Okay, so this property by virtue which relative motion between different layers of fluid experiences the viscous drag or viscous force. Okay, means because of this one, what happens, because of this good property of the fluid, they will oppose the relative motion between the layers of the liquid. Or you may have the different definition, the property by virtue of which there is the opposition made to relative motion between the adjacent layer. Okay, means you can understood here what is the main thing. There is the opposed to the motion of the flow of the liquid. Okay, opposed to the flow of the opposed to the motion of the flow of the liquid. Okay, means as liquid moving in the forward direction, it will get opposed, and that is what viscosity. So to understood this one, I will show this video explains you about the property viscosity. You observe the left side indicates the water and right side gives us the honey. Okay, so you observe that water flows and fills up in a glass faster as compared to honey. Okay, so what is that? Water having low viscosity while honey is having high viscosity. So why this so occurs? Because there is a friction between the fluid itself and its surrounding. Means the layers of the liquid are under the action of friction. Okay, this friction occurs in the solid, but in case of liquid as well as in gases, it is considered as a viscosity. Water is the less viscous as compared to honey, and that's why it will be take a less time to fill into the glass as compared to honey. Then we have to discuss difference between the viscous fluid and non-viscous fluid. So as you observe the diagram, in case of viscous fluid, you observe that the different arrows have a different values of speed. Okay, means the length of the arrow indicates the magnitude of velocity. All have a same direction, but all these are moving with the somewhat less or a greater value. And now what happens here, according to that, what we can say, as you compare the both one, in case of viscous fluid, all are moving with the different velocity, while in case of non-viscous fluid, all are moving with a same velocity. So up to that, different layers of fluid flows with different velocities. The central layer flows the fastest and the outermost layers flows the slowest. Just I told you, okay, in the case of pipe, the layers which are closer to the pipe are moving with a smaller velocity or less velocity, but the central layer is moving fastly. Okay, then in case of non-viscous fluid, you observe there all the layers are flows with the same velocity. In case of viscous fluid, dragging forces between adjacent layers are present. Means dragging force between the adjacent layer is present, while in case of non-viscous fluid, no dragging force between the adjacent layer is present. Then in case of viscosity of fluid is not zero. Okay, in viscous fluid there have a certain value of viscosity, but in case of non-viscous fluid, viscosity of fluid is 0. You can take an example in case of viscous fluid as a river flow. Means in case of river flow, you can observe there when the river is flowing, the bank of the river or the water flowing at the bank should be the having slower velocity as compared to its center. Means the water flowing in the center is have a maximum speed or velocity, but at the bank you observe it have a less speed or velocity. In case of non-viscous fluid, we take an example of liquid helium at about 2 Kelvin. Okay, means liquid helium shows the non-viscous nature at 2 Kelvin. So this is about your viscosity, viscous fluid and non-viscous fluid. Okay, so if you have any doubt, you can ask me into the section of comments. Thanks for watching video.